Well, here's what I want to do today. First and foremost, I want to play a bit with DSPy. What the heck is DSPy? Well, it's a bunch of AI stuff. So it's DSPy.ai. This is what I want to do today. Maybe like a small demo. Just code something up. And what DSPy is, it's this nice, well, let's just read this. It's a declarative framework for building modular AI software. It allows you to iterate fast on structured code rather than write brittle strings. Instead of wrangling prompts or training jobs, DSPy, which is declarative self-improving Python, enables you to build AI software from natural language modules. Yeah, this is let's see, they have a GitHub too. The way I like to call it these days is this is like a prompt management framework. I've been using this at work. It's like either prompt management, or I also like to say it's what PyTorch is for neural networks, DSPy tries to be for natural language. So it's just a framework to write AI functionalities without too much prompting. Actually, it says that here. Think of DSPy as a higher level language for AI programming. There's a bunch of lectures and stuff. All right, and we're gonna have to start all the way from scratch because I don't even have Python installed here. I do have Visual Studio Code, but before we get to that one, I gotta install some sort of Python thingy. And I want to mess around with DSPy with some free models on OpenRouter. So let's install the Python thingy. The other thing is everybody that knows what they're doing these days is supposed to use UV. You're not supposed to really install Python anymore. So let's install UV. I'm on Windows, but it's a fresh account. How the heck do I install UV on Windows? Okay, so I just copy this into a terminal. Okay, well that worked. I just copied this and pressed enter. And then let me see if I can show the window here. Just sorry. I cannot show the terminal window for whatever reason. Well, that's fine. We're just gonna, let me make a directory here. Well, actually I can just make I can make a directory DSPy learning. And I can just type UVVNV. Okay, I think we're in. So we just have to install what now? I just gotta install DSPy, that's it. UV pip install DSPy. Okay, that seems to have done it. Actually, my bad, I could have shown you the terminal here in VS Code. Why don't I do that then? Where the heck is the terminal? Oh, here it is. Oh, nice. So I made a folder. Let's see what we have here. Yeah, so I made DSPy learning. Okay, so assuming we have a clean folder and UV installed just by running that one command, you just gotta do UV VNV Python equals 313. I do not have UV here. Interesting, but I do have it in my Windows terminal. Is it because of some path thingy here? Oh yeah, it's got to be this one, right? Oh no, I don't have it here either. Interesting. Okay, well, we gotta debug this now. So I have to remember, let's see. VS Code terminal, inherit path from PowerShell. Path is different for Windows PowerShell and VS Code integrated PowerShell, obviously. Oh, okay, I just gotta do this thing here. Okay. So let's restart VS Code. Okay, we have the UV now. What the heck is this warning? No. Command line, try, catch function, you want to relaunch the relaunch terminal. Okay. All right, we're in for good. So, assuming you have UV installed, which is just that one line in the browser we saw here. Well, we don't have it anymore. What you want to do is just make a directory, completely empty directory. Then you want to run uvvnv python equals 313. That's not how that works. Okay, we have to search docs for this one too. UV Python version. Oh, here it is. It's uvvnv -- python. Okay, my bad. So we want to do uvvnv -- python 313. There we go. It automatically downloads Python, everything. Don't have to install anything. Works on Windows, Linux, whatever. All right. And you have to do everything UV pip list, not just pip is not going to work here. There is no pip. And this is a completely fresh environment. So then the next thing we want to do is finally we want to install DSPy. And we go UV pip install. Okay, DSPy. There we go. Automatically solves everything. We're pretty close to writing an AI agent, believe it or not. Something like that. Good. So now we just want to write our first DSPy script. And we're just gonna open a folder. We're gonna open the learning folder we just did. Yes, I trust the authors. We don't need the agent for now. We do need a terminal for now. Oh, we're gonna have to install Python extension, I think, right? Damn, this is really fresh. Yeah. Python language support. Okay. We're gonna need the Python extension because we're gonna need it to detect our environment. Okay, well, this is busted here. Cannot be run scripted operation is running on this system. Dude, what does it want from me? Let's see. Relaunch terminal. Okay, Python environments. This is done. So now what the heck do I do? I have to open the folder. I already have the folder open. I just gotta make a. There we go. Let's make a main.py. And I'm in Python 3.13. Okay, the UV environment here. Yup, it's already selected. We are all good. Let's start coding an AI agent. And I actually have to change my stream title because there's no way we're gonna do the actual log thingy today. How the heck do I change my stream title is a good question. I gotta do it from here, sorry. Let's see, what do we have here? Stream manager. Well, okay, we just have to do this live. Because I have no idea how to change my stream title, so we're just gonna go how to change Twitch stream title in OBS while streaming. Stream information doc. Oh, I see, by going to your Twitch creator dashboard. Okay, well, I'm there. In web browser, adding the title and info there. Yeah, I don't know how to do this, but it's fine. Okay, forget about it. All right, so let's see. So we installed DSPy. Okay, let's start coding an AI agent. So what we want to do is so we have to, okay, so we can call an agent like, we can set the DSPy agent with something like this. So we import DSPy. We got to configure the language model, OpenAI GPT-4o Mini. The problem is we don't want to use API keys on the stream, right? And then you configure DSPy with the models. What we're going to also do is we are going to use a free API-based model. So if I go to Open Router, which is a pretty neat website, it's sort of like a meta model aggregator. You can use like Claude, OpenAI, ChatGPT or whatever, Gemini, all through Open Router. And then they also have free models because different providers choose to host their free models and make it available to Open Router. So let's use this NVIDIA one, which is actually hosted by NVIDIA themselves. And it's supposed to be free. NVIDIA Nemotron 3 Nano, 30 billion, active 3 billion. Kind of smells like that Quen 30B model. It's supposed to be pretty good. So what we can do is, okay, we just use the model. And let's, I don't remember if you have to set provider to. How to pass the provider. So we gotta look at how Light LLM does it. And let's see, do these guys have Open Router here? They do have Open Router. Aha, so they want you to preface the model with Open Router. Okay, so we gotta tell it Open Router / now what the heck is DSPy.language model? The first argument is the model. So we might as well just be explicit here and say model. Does this guy want a provider too? It does, but I don't think it works that way, right? What does provider do here? Control F, provider. Okay, if not specified, the provider will be inferred from the model. This should be, let's see, self-infer provider. If OpenAI is it is not, OpenAI is not the provider model for this. Return OpenAI provider, okay. Otherwise return provider. Okay, it just has a bunch of stuff here. Well, we don't care about this. We're not gonna fine tune anything. Okay. Okay, so we have a language model, we configure DSPy with it, then what? We have to write a module with a signature. So the way DSPy works is, I'm gonna skip to the thingy here because I know it, but DSPy has signatures which allow you to write what you want AI to do in as little words as possible, ideally, right? So the last thing we want to do now is we want to start writing prompts. But before that, let's what the heck do we want the AI to do? Well, given that the Nemotron model thingy that we use is it's for agentic AI and specialized for coding, let's implement a sort of coding task, right? So we're gonna use it. Let's use a class-based signature then, right? Because, and let's call it class task some basic prompt here and some fields here, right? So you write how do I write this? Oh yeah, it's DSPy dot input field, some brief description, and output. something, some other description. Okay, so this is the vaguest AI task possible, and this is not gonna work. But let's try running this, right? So then we have a task now. We just need a module. And we can call this module an agent, or let's call it a module, or let's call it a module, yeah. And this will just be a plain predict with the signature of the task. And we can actually run this. We can run AI on this task, which is a really dumb task, but this is good to learn what DSPy is and what it's not. So then all I need to do is output, well, let's call it prediction, is module, and I just got to feed in an input, which is, I don't know what this task is. I'm just going to feed in some input to the model. Perform the task. So we can call this define the task through a signature, through a DSPy signature. Use, or let's say define an AI module that solves the, that is templated to solve the task. And when we say templated, we mean prompted. And we actually perform the task on some inputs. Now let's, the inputs are generally, we can have an AI module that takes more than one input. So let's use a dictionary called inputs for the inputs, and it has a key and the value. Okay, in this case, there we go. So now we pass. Okay, so let's see, inspect the prediction outcome. Check this out. How the heck do I inspect the prediction outcome? DSPy view prediction history. I always forget this one. Oh, it's inspect history. You can call DSPy inspect history. Okay, so view the history of the last call. The last prediction outcome. And that is it. If I now go to a, where the heck is a terminal? New terminal. I get some really nasty errors here, which I don't know what the heck these are, but whatever. Can I run this? So I remember I'm in UV world, so I just do UV run main.py. Oh, I know, it was trying to activate the thing there. The only thing is, did I get the model right? So I'm using, oh, sorry, DSPy input fields, they have a thing called description. It doesn't work arbitrarily, okay. Let's try again, UV run.main.py. Come on. Is NVIDIA gonna let us use the free model? Something like that. No, it's not gonna let us. Client error 4103 for URL chat completions. Okay, I gotta check this one. What the heck? Client error 401. I wonder if this is a Windows error thingy. Let's see here. Receiving a 401 authorization to open an API. The highest probability is that you have a bug in your code or events and sent to API. Well, we don't have an API key. That's not the problem here. Check out the summary confirm harness GPT-3. Are we sure this model works like we think it does? Oh, let's see, what do we have here? So model. But do I need an API key? Because I really don't want an API key. I think I do. We do need an API key. Oh, I see. There's a free and the standard one, but for sure we're using the free one. I see. So they do want to track you with an API key. Let's try and find some other free models. LLM free models. Can you use free models on OpenRouter without an API key? Yeah, even for free usage, 50 free model requests per day. Okay. Well, this is not good because I'm not prepared to do this on stream. There's a Pewter.js thingy, but this is way too complicated. So can I set okay, let's do it the hard way then. So I gotta open the command palette in VS Code and search for open configurations. Control-Shift-P, open configuration. This is not what I want. Launch JSON. Launch. Oh, come on. Where the heck is environment? Terminal. Show environment contributions. Yeah, this is not what I want. Debug open configurations. Debug open. What? Add configuration. More Node.js. JavaScript debug terminal. Okay. This looks pretty close. Yeah, this is the one. So configurations name. So I just need env. Okay, so I need an env in configurations. Gotcha. And then it's going to be open router API key, blah, blah, blah. We're not supposed to show that on stream. Let me double check. Is it like that? env. Yeah, it is like that. Okay, so is it open router API key? It is open router API key. So then what if I do stuff? Oh, but wait, this is JavaScript debug terminal. What? This doesn't look right. So I don't want this. Debug. What the heck is this, dude? Python debugger. I guess it is this. Okay, so what the heck do I do? Terminal, new terminal. Not that this works. Okay, how the heck do I, let's see. View, Windows, environment, variable by name. Oh, I see, it wants echoing percent signs. So do I have anything here? No, I don't have anything there. Nope. Oh, let's see. So it's echo $env open router API key. No, it's not here, dude. Why? Oh, I see. Does it want the thing too? Nah. Do I have the whole env? No, I do not have the whole env. Maybe let me try restarting this thing. I don't need to activate it, but I do need to. No. We don't want permanently. Okay, I'm so dumb. So you can set variables that will be future interior terminals. Open settings, control comma, search for your platform specific settings. Okay, this is what we want. So open settings, control comma. What did it want then? Search for your platform terminal integrated env windows. Aha, edit in settings.json. There we go. So then we have my variable, so open router API key secret. Okay. Restart VS Code for changes to take effect. Okay, this better work. Visual Studio Code for changes to take effect. Okay. Shit, I need to find out what else I did here because here it is. Okay, I need to undo this thing here. I don't know what this is. Okay, and now we go terminal, new terminal. Close this one, clear, echo. Whoops. Come on, open our API key. No. Aha. Okay, well, that's pretty nice. Okay, so now we have this thingy here. Here's a good one. Let's see if Python sees it. So import OS. Check if the variable is there. Print os.environment open router API key, because then I can just do terminal, new terminal, and I can drop into a Python console, UV run Python, import OS. Pretty good. So we got the thingy here. So then what I have to do is, how do I pass? I believe it's API key, right? Oh, it's not? Nah, yeah, okay, so I don't need this then. Is it? It is API key though. Why does it tell me not? So then we need, definitely we need OS here. Let me put it on top. Okay, we need API key is os.environment open router API key. What else do we need? API base? I don't know about that one. Actually, let me try it like this. Interesting. I wonder if it's gonna fool them. So if I run uv run main.py, we'll see a key now. Nah, it's definitely okay. So it's an authentication error. Yeah. Okay. So no cookie authentication credential. All right, so let me make an account now. That should be pretty fast. It's coming soon, so let me turn this off for a while. Okay, there we go. Where the heck is the email? Oh, come on, dude. Can't believe it's so slow. Where the heck is my confirmation email? Are these guys insane? Why is it so slow? Oh, come on, man. Okay, I figured out how to change the stream title. Dude, these guys are insane. Like, that confirmation email is not coming from OpenRouter. What the heck is this? Oh, is it spam? Oh god, it is spam. Okay. All right, so let's see. Then I have to go. Okay, stream key. Okay, that should be it. I think so. Let's see, what do we do here now? Okay, I can put this back on. Then if I go to a terminal, I really wish it didn't try to run this stupid activate thingy, because we don't need it to activate my UV environment. Then I can run UV main.py, UV run main.py. Oh, there we go. Oh my God. All right. So this is DSPy. Okay. Well, here's an interesting one. Okay, finally. So we have full-blown AI working, right? So you're gonna have to make your own. I'm not gonna show the OpenRouter API key, even I'm not dumb enough for that. But we use the NVIDIA free model. So then, okay, finally, let's get back on track. Oh my God, sorry about that. So what the heck did we do here? Well, we chose the language model. Okay, so it's a 30 billion active 3 billion language model. And we use the basic template, which comes from DSPy.predict, to solve the task, which is very vaguely called task. And this is all natural language, right? So DSPy is sort of moves natural language to Python world, but we're still dealing with AI, so it's still all natural language. And I just realized, well, hang on, my bad. Okay, there we go. Okay, my stream was not frozen. Sorry about that. Okay, so then we have this thingy here, and so we're solving the task with the DSPy.predict. Now, what is the task? Well, the task is very vague because the task description goes here, and it just says some basic prompt here, and the task has one input and one output, and they're called input and output, and they have the vaguest descriptions in the world. And then we also pass the actual input, which is a string called some input. Okay, so this is all very confusing, but this all turns into a prompt for modern AI. And the prompt for modern AI generally has two parts. It has a system message and a user message, right? The system message is the one called system prompt. You see this all the time. So DSPy writes all this for us underneath the hood, and it describes the task to the model in a way that kind of starts to make sense, even though we wrote it in the dumbest way possible. The system message says to the model, your input fields are, the first input field, 1, is called input. Very vague name, but we're the ones that type it. And semicolon, some brief description. That's it for input fields, right? Because we did not write another input here. We can have AI use two inputs by just writing another input, or called other input field with the description, some other brief input description. Okay, so now if I run this thing again, there we go. So now your input fields are 1 and 2. Now they're still badly named because it's still my job as an AI user to figure out what I want the AI to do. But in this case, I want the AI to take two inputs, which have the vaguest names ever and the vaguest descriptions, and to produce one output. I'm the one that wrote this here, right? So your output fields are one. There's only one because, again, I could have asked for three outputs here. I'm not going to do that. And actually, let me ask for another output. Let me do that, but not a string. Let's say I want a Boolean. Okay, so DSPy also works with base, or actually, let's ask for an integer. And it's another output field. How many inputs were there? Now this one is a bit more interesting because this is already, if I look at this as a human, I know what the answer to this should be. It should be 2, okay? If I add yet another input here, which is an integer, and has a description, my age in years. Now I know that another output should be 3 now. These other guys are still dumb because input doesn't tell me anything. It's just some brief description. Other input is something else. Yet another input is an integer. It kind of starts to tell me something because it has a natural language description. But it also has a really, really dumb name, right? A better name, because the variable names do matter, would be age. Okay, so now let's rerun again this program. And I forgot that we now need to specify all 3 inputs. So what am I going to do for input? Some input, because I have no idea what that field is. For other input, I'm going to put other input. For age, I'm going to do 25. And I'm going to predict with these inputs. Back to DSPy now. All right, we're starting to have something pretty interesting going on here. So now we have an AI module, which starts to get really complicated. It has 3 inputs and 2 outputs. Again, it has 2 string inputs. The first is called input and has the vaguest description in the world, which literally reads some brief description. I don't know what this is. It's a string with some description, okay? It's if somebody hands you a piece of paper and you ask them what is written there and they answer something. The other piece of paper is another input with some other brief description. The third input is a more interesting one because it's called age. It's an integer and represents my age in years. Okay, so now I pass 25 to this. The AI can actually do something with this. Even you as a human, this is something else. And then we describe the output fields. The first output is called output, some other description. How the heck is this related to the input, or how is the AI supposed to predict output from the inputs? I have no idea because I'm the one that wrote this and I'm dumb. The second output is called another output. The name is bad, but the description is not. It's an integer and says how many inputs were there. So if I look at this now, it would better be 3, or else the AI is really bad. If this is not 3, then the NVIDIA model that we use, the free one, can't even do a basic natural language counting task, right? It's as if you tell a human, I'm gonna tell you a few things, and I'm going to ask you some questions about them. And one of the questions is, how many things did I tell you? And you'd better know how to answer that. The first question is still dumb because you need to predict output, which has nothing. It's like something from something. DSPy also, so again, we're back in DSPy here. So it does all the prompting for us. So then the prompt template keeps on going. So first it describes input fields, output fields. It describes how the interaction will happen. And this is all a prompt that goes to the model. We didn't write any of this, right? All interactions will be structured in the following way with the appropriate values filled in. Then it puts these nice headers And this is how the user message will be presented. So it arranges the inputs in the order they're presented. So in this case, there's 3 inputs, then followed by the outputs. For some outputs, depending on the type, it gives the model instructions. For example, the output called output, I know, really bad name, we're changing that, don't worry. Sorry, water break. The output called output is a string. It doesn't have any special instructions. The output called another output is an integer. DSPy behind the scenes does add a special instruction there. It says the value produced must be a single int value. And this makes sense to a human, right? If I ask you, tell me a number that represents something, you'd better not tell me 2 numbers or 3 numbers or 57 numbers. I just want 1 number and I want it to be an integer. I also better not see 23.5 or something, a floating point. Okay, and then it describes what it must do. In adhering to this structure, your objective is, we didn't write anything here, or I wrote the dumbest instructions possible, some basic prompt here. And this is the task description, right? So the model sees 3 inputs and must magically, using artificial intelligence or real intelligence, it's got to figure out how to predict the 2 outputs from the 3 inputs. Now, as a human, the first one is impossible because this is like a teacher asking you a really bad homework question. Well, not bad. It's almost like a teacher telling you that for next week, your homework is something. And that's it. And then next week, you're going to get graded on it. Well, what the heck are you supposed to do? I don't know. Good luck figuring that out. But the second output is not dumb because it has a description. It's like a teacher is coming to you and telling you for next week, your homework, or the second problem in your homework, will be to count how many problems we talked about this week, or something that represents inputs. In this case, it's 3. Okay, so then the user message actually feeds in what I gave it. And in this case, we already find a bug here because for input, I gave it some input. For other input, I was supposed to give it just a string other input, but I don't know why I'm seeing this doubled, which is really freaky actually. Let me run this again. Something is wrong here, or maybe DSPy needs bug fixing. Aha, no, okay. It's a stupid console bug, I think. Okay, so then the user message has the 3 inputs, okay? Input, other input. The input doesn't tell me anything because it literally reads some input. The other input doesn't tell me anything. The age tells me a 25. And then finally, the message asks the model, respond with the corresponding output field, starting with the field, then blah, 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 must validate, and then ending with the marker for completed. Finally, the green stuff is what the model predicts. So this is real AI response here in green. So remember, we're back to the structure of the problem. What do you think the model predicted for output? Well, the model did a pretty good job actually, because it predicted back a vague thing. Right? So remember, what is the description of the output? It's the vaguest description in the world based on the vaguest inputs in the world. If you give me this question, it's like, so again, you're the teacher, you're a bad teacher, and you tell me your homework for next week will be something. And then the next week comes, and I have to present my homework to you. What am I going to tell you? Hey, teacher, here's something. Okay, so this is the predicted output. Process description based on the provided inputs. Does it really tell you anything or answer any question? No, because we asked the wrong question and we gave bad information to the model. But remember, our task had two outputs. It had another output, which was supposed to be an integer, which represents how many inputs were there. And interestingly, this I can't tell you. It's 3. Obviously, it was 3, right? Because I had 3 inputs. And then the model completes the response with completed. So let's see, it's not just a hard-coded 3, and let's delete one of the inputs, right? So now we just have an input called sum input and an age of 25. We run again. Oh, there we go. So again, now we just gave 2 inputs. One of them is vague. And there's a sorry, there's a console bug or something, because I should really see. Damn, I really don't like this Windows console thingy. Okay, the age should be 25. Yeah, is it 25? Is this a bug? This has got to be a scrolling bug or something, right? Yeah, it is 25. I see. So if I make this smaller, damn, this is so dumb. This is why Windows is not the greatest. Maybe we'll switch to okay, well, whatever. I gave it 2 inputs and I got 2 outputs. Again, the first output is literally sum output. Very cheeky model here, because you ask for vague things, you're gonna get vague answers. But the other output, which actually has a meaning, is 2. So it's not a fluke. There is real intelligence in the sense of natural language processing to be able to basically count the number of inputs. Okay, so let's turn this into something more real. Now so we're at a crossroads now, because we have a model, we know how to do complex AI now with hundreds of inputs, hundreds of outputs. Let's complicate the prompt template a bit. Well, actually, no, before that, let's fix the task, okay? Because I don't know what this is. So what do we actually want the model to do? And let's stick with 2 inputs, 2 outputs. This is a sufficiently complex AI example. It's not just one answer, one question, one input, one output. So let's ask for some Python code that does something. And let me look a bit here. Let's see, what do we have here? Let's try to think of something interesting to do. But before we do that, I'm gonna take a break. So let me see. Yeah, I'm gonna take a small break before we do that. We'll be right back. All right, we're back. Let's see what's going on here. We got some tea. Okay, so let's do something interesting. Let's do... So we now know how to write AI modules that solve arbitrarily complex problems with many inputs and many outputs. And we can specify what the inputs are, describe them, and what type they should be. This is going to play a big role. So let's try to do something useful. Let's write an AI module that solves data structure DSA problems, so lead code style problems, and also generates code that verifies that the solution is correct. Let's think of that. Okay, so let's go back to the ground stage here. Okay, so we write DSPy modules. So then I can, the first and the most important thing I can do is I gotta rename this something other than tasks. So we're gonna call this a problem solving. This is the signature, okay? The basic prompt is no longer the basic prompt. And the inputs can be called problem, which is a string and has a description. And the cases will be a list of lists of integers. Okay, so this becomes problem solving. And the solution and the test are the two outputs. Okay, so this is how we write advanced AI modules. Okay, the solution will not be a string. We want code. So DSPy has this thing called DSPy code and the language of the code, which is pretty neat, Python. And we want the test to also be code in Python. Okay. Now we need to finish writing natural language descriptions. So what do we want this module to do? The doc string here in DSPy, if you read the signature docs, this is your one chance to instruct the module, yes, which ultimately goes back to instructing the AI on what it should do here. So this is basically a classical, but let's say lightweight prompting thingy here. So you want to say something like, you are an expert in solving algorithmic problems using Python. Okay, so let's split this in rows, right? What else do we want to tell the model? Not too much. We don't want to over prompt it. That's kind of the whole point. So using the whole point of DSPy, using the problem description in problem and numerical examples in cases. So let's make this even brief. So use the problem description to output a solution and test code. Do not avoid using a brute force solution unless it is the only way. That's it. This is already over prompting, okay? And then the nice thing is we already kind of described the fields here. So then when I have to re-describe them again, I can be a bit more brief here, okay? So AI, 2 inputs, 2 outputs. The first input is a string called problem, and what do you think this does? Well, it's the description of the problem to be solved. Okay? Cases. This one is a bit trickier because this has a complex annotation. So we need a convention here. Why did I write list of lists of integers? That's a good question. So let's see. So let me do it this way. List of integers. Let's do a simpler convention, right? Well, actually, okay. It's a list of tuple of a list, an integer, and an integer. Okay, bear with me here, right? So, each examples of inputs, possibly more than one, paired inputs and output, always one, for the problem. So now we already baked in a lot of structure here, because what I would like this to be is, and we'll get back to this. We'll have to be careful with the cases here. But if you read, the point is you want the AI to have enough info here, though you can't be too vague, right? So if I have to say something, I'd better say it here. So a list of paired inputs and output for the problem. So this is a list, and then the list, each list element is a tuple, so it's a pair of 2 things. All the inputs that go in, possibly more than one, so hence a list of integers, and the single integer output. Now this actually constrains the problem a lot, because if I'm a sort of a smartish human and I read this, I don't know what again, we want this AI module to solve any problem in the world, ideally, right? But I already know this is not going to work. Why? Because I already constrained the inputs and outputs to be integers, which is a pretty strong constraint. Like, I will never be able to solve problems that calculate floating point values, just because I would be lying to the AI if I said that. There's also another constraint that the problem must have a single integer output. I'll never be able to solve problems that require 2 outputs. I could make this, this could easily be made into a list of integers. So let's do that. Okay, so then we can simplify. A list of paired inputs and outputs for the problem. Okay, so then it's a list, and it's a list of pairs, and the first thing in the pair is a list of inputs. The second thing in the pair is the list of outputs. Now, I've made the problem more relaxed here, but I'm still constrained to integers. I can use any here, I can use any pydantic annotation, but we're gonna skip that for now, it's fine. Okay, moving on. So we know what the problem is. Is this enough for you as a problem solver? I think so, right? Technically, even these cases you do not need as a problem solver, okay? So I'm actually doing you a favor. I'm helping you out here a bit. I'm not only going to tell you what the problem is, which should be enough. If I say this right, now we're still going to have to call the model here, okay? So now, by the way, when we actually call the model, it's going to have 2 fields now, right? The problem, which we're going to actually have to describe a lead code or an algorithmic problem. And I'm also going to have to show some cases to the model. But you know what is also a valid list of tuples? An empty list, by the way. So this AI module will also work if I decide to show, I will show you a list of cases, but 0 cases. So we'll try out everything, but ideally I would show something like this, right? Because I said a list of tuples and each thing in the tuple is a list, okay? So this is one example. This is another example, etc., etc. We're gonna have to write these by hand because I'm the one and we're gonna have to write the problem description. And we're done with the inputs. Now let's describe the outputs. So the solution is code, Python code. So code that when executed with the inputs produces the expected outputs. So this is basically how to solve something with code, okay? Or at least a functional way, which we know is good. Functional programming is a good thing, yes. Just give me 1 second. All right, we're back. Let me see what's happening here. Maybe I can make myself a bit smaller. Yes, I can. Okay. All right, so where were we? Okay, so we wrote the inputs to the AI module. We got to describe the outputs. We finished one test. What the heck do we want the test code to do? Code that tests the problem on the provided cases. Now this one is tricky-ish. Maybe it is, maybe it's not, but it's sort of actually similar to the counting example we did. Remember in the dumb world, we had the AI count the number of inputs. This is kind of similar because it's an output field that directly references the input, okay? So what I'm telling the model is, I want you to output some Python code. I want you to output 2 pieces of Python code, okay? One that is the solution to the problem so I can run it on my own inputs. I also want you to actually use that code, test the solution on the provided cases. So we made this even trickier now because I'm telling the model, look at what you just output and use it on the cases. Okay, and that's it. This is AI. This is complicated AI now, by the way, because DSPy will handle all the templating. We'll see how that looks like. Let's find the problem though. That's the thing we're missing, right? So let's go to lead code. And let's pick something. Where the heck are the problems? Oh, here they are. Okay. Let's see the problem of the day. Apple redistribution into boxes. Remember the constraints. It has to be integers to integers. Well, well, not really, because we want a single. This would almost work, except it has 2 inputs, and we don't want to mess things up, right? Yeah, this is gonna become too messy. Almost. Let's look at problem 1 then, the most basic one. It still has 2 inputs. Okay, I need lead code problems that just have a single input, single output, but they can be lists. And they have to work with integers. Is there a way to solve? Okay, so I'm gonna do array. Remove duplicates from sorted array. This one looks promising. Yes, this works, okay? Because I have an input that's a list of integers and the output is a single integer, which is also a list of integers, but with 1 element. Okay, that is it, okay? So I'm just gonna dump this whole thing. And this is the problem I want to solve with AI, okay? So let's do the triple quote thingy in Python. Let's see, where are we here? Okay. There we go. So I have a problem now that I want the AI to solve. And it reads, how do I turn this panel off? Yikes. Okay, I don't want the minimap. Good. Can you guys see me here? I'm a bit... Let me move myself, actually. What if I move myself here? This looks a lot better, right? Yeah, this looks good. All right. Good. So now we have the problem. Given an integer array, nums, I'm going to do some formatting here. Sorted in non-decreasing order. Okay, there is some weird Python formatting here, which I don't... What the heck is this? Yikes. I gotta sanitize this text somehow because this is really bad, right? So can I just copy it here and then copy it here? This should work. It does work. Okay, good. So given such appears only once. The relative order of the elements should be kept the same. Consider the number of elements to be k. Why is this weird here again? What the heck is this k thingy here? No, it's just k. Is this like a VS Code thing? Oh god. Well, this is really sketching me out now. What the heck is this, dude? What is this character? Yikes. Okay, well, let's see. If I delete everything... Okay, I really don't like that weird character thingy. So then I'm just gonna go and... let me take this into the Notepad++ thing. There is a special K there, which I don't know what that is, but yeah, okay, interesting. Which is very freaky. I'm just gonna type it by hand because I don't want to deal with that. So consider the number of in nums to be k. After removing duplicates, return the number of unique elements k. Well, actually, let's keep the problem like this. Okay, so given an integer array, nums, in sorted in non-decreasing order, remove... we can shorten this, right? So given an integer array nums, consider the number of unique element in nums to be k. After removing duplicates, return the number of unique elements k. That's it. So just some Python code that this is like really easy to solve by hand, right? You just have an array that's sorted with possible duplicates, and you want to remove duplicates and return number of unique, well, we don't even need the remove part, right? Return number of unique elements k. Okay, so let's give the AI some cases, right? So what do we say here? In non-decreasing order. So for example, 1, 1, 4, 6, 7, 9. What is the answer for this input? 5. There's 5 unique elements. 1, 4, 6, 7, 9, okay? Another example for the AI. 4, 4, 4, 4. The answer is 1. Okay, another example for the AI. 26, 999, 1003. The answer is 3. And these are probably enough examples for, even for a human to figure out, okay, I kind of know what the heck is going on here. I'm ready to solve the problem now. So let's solve the problem. Well, we don't have to solve the problem because we have AI that's specialized to solve the problem now because of DSPy. And that's it, right? So I have the inputs, the problem. Let's see what DSPy does. This is gonna be amazing. So terminal, new terminal. Oh God, I hate this Windows thingy. All right, let's pop the history. UV run main.py. We're actually using the model. It's gonna take a bit now because it's predicting things. Okay, so again, this is a giant prompt which we did not write by hand, thanks to DSPy, that does all the prompting for us. It says your input fields are problem, description of the problem, cases, a list of paired inputs, outputs for problem. The output fields are solution, code Python, test. It also, by the way, DSPy also is starting to get better for handling code because it also instructs the model to do backticks and extracts the code automatically. Which we shall see how from the prediction. Right now we're seeing the raw prediction, but it has more functionality. Okay, I did the thing again with the scrolling, which messes up the thing. So let's just run the AI again. And let's just copy this actually. Well, let's do even better actually. Why copy? Is there a way to store this history? Oh yeah, there is a way to return predefined history. Okay, so I can go history. With open history.txt, right, as handle.write history. Okay, so let me just write this thingy here so we don't have to do the terminal. And I believe now it should suppress it from the console and we'll be able to actually open that file. Ooh, what is this? I see, pretty print history doesn't actually return anything. Oh, come on. How do I save? Sorry about that. Let's see. How do we save? DSPy inspect history. I don't want to do the whole thing here with ML flow yet. But where can I not get the history? Is this for real? Can I not get the, okay, so then I have to do Python intercept standard output, redirect standard output to file, right? Yeah, I have to do this. Well, whatever, let's just do this thingy here. Because I really don't want to print to console anymore. So let's see, with open history.txt, okay, so this is fine. So we need to import sys. Sys. Oh shit, what did I do here? Oh, I see, this is the handle, right? So it's handle, and I don't need this, but I do need DSPy inspect history, right? Restore standard output to the original. Okay, so this should do the restore. Do I need this thing here? Original. Maybe I do. I'll just keep it like this. Yeah. I don't need this. Okay, so then we can, I can just run this now. Run. Can I just run without debugging? Maybe not. Terminal. No, because I gotta do the UV thing. God, I hate this thing. UV run main.py. Okay, there we go, finally. So now what do we have here? Aha, history. All right, we're back in business now. So this is what happened to the, remember, we are implementing, is there a wrap thingy, please? Oh yeah, there is a wrap thingy. Good, perfect. So we implemented an expert AI system that takes two input fields and outputs two outputs. The two input fields are problem, which is a string description of the problem to be solved. Another input field is cases, and we want a Python code that represents the solution, so code that when executed with the inputs produces the expected outputs. And we want a test code too. Okay, so then DSPy blah 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 does all this thing. Let's see what we actually gave the model. Well, we gave it the problem, which says given an array, an integer array nums sorted in non-decreasing order, consider number of unique element in nums to be k. Return number of unique elements. Okay, so this is a very basic lead code problem, but let's see what it outputs. So it output a solution field, which is it does a JSON format, but there's a code here, which is a Python code, which is supposed to solve the problem. And it also outputs some test code, which hopefully tests the problem. And I'm pretty sure this is going to work nicely, right? Because it actually used unit test. Okay, so now let's see it this way. So let's see. Let's also write the Python code to files, because we don't, you can see here that DSPy has this weird JSON output, and it has a field called code, and it has backticks in the language. But actually, if you look inside the prediction object, that code is already extracted there. So with open, so let's make a directory. Make dirs solution. So with open solution.py, and we're going to write the solution here as handle.write solution.code. Okay, so we can access this pretty easy, and then we can also write the test code test.py w as handle.write prediction.test.code. Let's run this again. And this should be pretty nice now. We're actually pretty close to getting the full thing. Okay, everything worked. So what do we have in the file structure now? We have a folder solution. Here's the code and the test code. Okay, so we just automated problem solving, because now I have a function in solution which takes as input a nums array. And let's look at this code. Does it do what we want it to do? Well, if the array is empty, it returns 0, which is the right answer, by the way. I never said in the problem description here, did I ever say that the array has at least one element? I didn't. So the AI, like a human, minus the interactivity part, of course, because the AI never got a chance to ask us questions. Maybe we'll work through that in a more advanced example. But this kind of works because the AI inferred that, okay, if the numbers are empty, return 0. Else, I have at least one unique number. And then for each element other than the first, if it's equal to the one before, if it's different than the one before it, I'm going to add +1. This is a smart solution because the AI also used the fact that the array is sorted in non-decreasing order. So if I check this array, I don't have to check 4 against all the previous values. Or let's say 7. I don't have to check 7 against 6, 4, and 1. I just got to check it against 6 because I already know that 6 is different than the ones before it and that the array is sorted. So if this is unique, there's no 7 before it here. Pretty good. But even more important, the test code, which is also AI generated. So this is sort of a self-test code here. It output the function again, and it also wrote a test class which tests it exactly on these cases. And then what we can do is we can just go to solution and we can say UV run test. Okay, the test passes. So then I can write my own test cases here. So if I put 56, 56, 99, what is the expected answer? 2. If I put a 4 here, I'm going to get a test fail here. There we go, failed. 2 is not equal 4. So then I have to write valid tests. Okay, that's it. So we just wrote an AI agent that solves LeetCode problems. And this template here is generic. Now, if I want to solve another problem, I'm just going to change the inputs, right? So all I have to do is, let's do another problem then. Okay, so we'll just write one ourselves. And let's write some cases too for it, which we will write ourselves. All right, so let's write a problem, another one. Let's make something up on the spot. So let's say something like this. So given an array of integers, nums, return a list containing the lowest and the smallest, including negative, and largest pairwise differences between all elements. This is also an easy problem because I can just do min minus max and max minus min. And that's it, right? So let's put a twist to it. So given an array of integers nums and an integer, a positive integer k appended as the last entry of nums. Okay, return a list containing the k smallest and k okay, so let's do it this way. Return 2 lists. Okay, so now for this, now we notice that we want to solve a problem with multiple inputs and multiple outputs. What is the problem? The problem becomes the cases code, because I wrote this as a list of tuples. Now the thing is, if I have multiple inputs and multiple outputs, I just have to make this a list of lists. Okay, so all possible inputs and all possible outputs. And there we go. That's how easy DSPy makes it to convey this sort of information. You can think as a programmer. You don't have to write anything in words, right? And this description is still correct. A list of paired inputs, which themselves could be lists, and outputs for the problem. Okay, good. So now how do we change? Let's change the old code back. So this is now like this, right? So the first input is a list of 4s, and it's only one input, and the first output is a list of 1s, which is a single element, a single input, blah, blah, blah. Okay, so just with another list, we're done. Okay. Okay, so now let's do some cases. Now this one's gonna be trickier because as a human, oh my God, I have to work through this through paper. So we have 2 inputs. So the cases is a list of tuples, and each is a tuple, and then we have 2 inputs and 2 outputs. And because I'm a human, I don't want to do this by hand for everything, so I'm just going to do it for one case. Okay, so the first input is the array, not sorted. So 23, 1, minus 5, 4, no, 5, 5, 0, 8. K, I'm going to pick 2. So now, the answer must be a 2 list containing the k smallest, including negatives, and k largest pairwise differences. So the 2 smallest pairwise differences and 2 largest pairwise differences. And then we need to specify something else. Each of the output lists should be sorted in ascending order. Okay, so ascending means smallest first. So the first element of the first list is the most smallest, the most negative difference, which is minus 5 minus 23, that's minus 28. The second smallest difference is, you still want to take out 23. I believe it's minus 23 because it's 0 minus 23. I don't think you can do something between that and minus 28, right? If you do 1, you can do minus 5 minus 0 minus 5 minus 5. Yeah, okay. Now, the k largest pairwise difference, so the second high, and this is also sorted in ascending order. The second highest pairwise difference is, well, these are easy because they're the duals of these, 23, 28. So there's a trick to this problem, right? Because the second answer is the reversed and negated first answer. Boom, and we're done. Only if there's negatives. Actually, that's a mistake. There's an anti-pattern here, right? Let's do a more basic case. Should we give the AI a more basic case? I think we shouldn't. Okay. So let's see if the AI falls for this trick, because the anti-pattern here is if I have, so let's write another thingy here, right? So I have 2 inputs, 2 outputs. So what if I ask you for this? 1, 3, 4, 9, 10. Which ones are the most negative differences? Well, it's 1 minus 10 minus 9. And 3 minus 10 minus, no, not minus 7. 1 minus 9 minus 8. Okay? Now, which ones are the 2 largest differences? Okay, well, never mind. Wait a second. So what? Oh, I see. So it's always like this. Okay, yeah, so it is a trick problem. Okay, never mind. Yeah, I'm dumb. Okay, so, but anyway, let's see if the AI can figure it out. Actually, this is a good, well, okay, let's do it this way. Can the AI figure this pattern out then and not compute both of these, because once you do the first one, and this is just a telescoping two-pointer approach, right? This answer is always max minus min, and then you either increment the max or the min, and you pick the winner and you move on. So as a sort of an expert programmer, we can sort of see the solution, but it's not the easiest one, right? This is still a lead code easy problem, but not the easiest one. And that's it. That's all I have to do, which is pretty amazing, right? So now I can just run my AI on this thingy here. I hate these consoles. And just to run UV run main. Okay, the AI is thinking, so we're actually, thankfully the model is free, so we're paying for it, but well, somebody's paying for it. Okay, it's done. Now let's check the solution code. Okay, a lot more verbose. Okay, so it did a brute force approach, which is not good at all. So it did nums and k generate all ordered pairwise differences. And it did this is a disaster approach, right? Because it's n squared and sort and return smallest, largest. And the test code looks like the same thingy here. Let's see, does the test code pass is the question. And do we have our other UV run test? It does passes. It does pass. And do I have my other case I wrote here? Oh, here it is. Okay. So then if I take, let's test this one now. So if I test with this number and k equals 2, I really hope to see these guys. Okay. Let's see, does the test pass? It does, except okay, I see, so he only wants like this, right? Yeah. Yeah, so there are some conventions that, okay, yeah, so the code works. That's it. The problem is the AI solved this with brute force. And we can't really tell that or know that until we manually inspect the code. But then if you think about it, what I mentioned earlier in the beginning of the stream is that DSPy is supposed to be what PyTorch is for neural networks. And then the thing there in PyTorch, if you know a bit about PyTorch, is that it's all about composability. Okay, so even with transformers, which are like the architecture today, you can just compose layers, right? That's pretty much what a transformer is. So then you can do the same with DSPy. We can compose AI with itself. So if you think a bit outside of the box, you can kind of guess what the solution to this brute force problem is. We can just have another module that inspects the output of this guy and gives it a hint to refine the solution. But I don't think we're going to do that today because it does involve, well, it's actually not, well, no, it's not hard at all. It doesn't involve anything. But yeah, that's something to maybe we'll do tomorrow. So I didn't have any viewers, but that's fine. Okay, well, I hope this was fun and educative, and I will see you next time.